For millennia, they have slept, entombed in a prison of pure ice, locked away from the sun, the wind, and the flow of time itself. These glaciers, these vast rivers of frozen water, are more than just stunning landscapes. They are time capsules. They hold the air of ancient atmospheres, the bodies of long-extinct creatures, and the secrets of worlds long since vanished. But as our planet warms, these icy vaults are beginning to crack open. And as they melt, they are not just releasing water. They are releasing ghosts. Not ghosts of specters and shadows, but something far more tangible, and perhaps far more dangerous: ancient pathogens, viruses that last infected a mammoth, bacteria that shared the world with the Neanderthals. The question we are forced to ask today is a chilling one. As the ice recedes, what threats from the past are we awakening in the remote frozen soil of Siberia, known as Permafrost? A team of scientists made a discovery that sounded like it was ripped from the pages of a science fiction novel. They weren't digging for dinosaur bones, they were drilling for ice. Deep within a core sample, taken from over 100 feet below the surface, they found something astonishing. Preserved in the eternal freeze was a virus. But this wasn't just any virus. Radiocarbon dating revealed it was 30,000 years old, a contemporary of the last ice age, a time when woolly mammoths still roamed the earth. They named it Pathovirus sibericum. And to prove it was still alive, still viable, they did the one thing you only see in movies. They carefully brought it back. In a secure biosafety lab, they placed the ancient viral particle in a petri dish with a modern amoeba, a simple, single-celled organism. Under the microscope, they watched in a mixture of awe and horror as the virus, after 30 millennia of slumber, sprang back to life. It invaded the amoeba, hijacked its cellular machinery, and began to replicate, creating hundreds of new viruses, effectively ending its long dormancy with a burst of predatory activity. The most crucial detail: Pathovirus is a giant virus, so large it can be seen under a light microscope, and it is unrelated to any human-infecting pathogens. The scientists chose their test subject carefully for a reason. This was a proof of concept. The ice was not just a preserver of life, it was a deep freezer for infectious agents. The question was no longer if viruses could survive, but what else was frozen down there, waiting for a thaw. The discovery of Pathovirus was just the beginning. Since then, other ancient viruses have been found, some even older. The permafrost and glaciers are not selective archives. They preserve everything that fell into them and was quickly frozen. This means the frozen north is a vast, unmarked graveyard. It contains the bodies of animals that died of ancient diseases, a woolly rhinoceros found with lesions that suggest an infection, a mammoth carcass that may have succumbed to a prehistoric plague. When these carcasses thaw, they rot, releasing whatever was inside them back into the water and soil. And it's not just viruses. Bacteria, like anthrax, can form incredibly resilient spores that can survive frozen for centuries. We have a stark, real-world example of this. In 2016, in the Yamal Peninsula in Siberia, a heat wave thawed a portion of permafrost that contained the carcass of a reindeer that had died of anthrax decades earlier. The spores were released, infected grazing reindeer, and ultimately led to the hospitalization of dozens of people and the death of a child. It was a tragic, small-scale preview of the potential danger. Anthrax is a known quantity. We have vaccines and treatments. But what about diseases that have been absent from the world for thousands of years? Diseases that our ancestors, like Homo sapiens and Neanderthals, may have faced, but that modern medicine has never seen. Our immune systems would be completely naive. We would have no natural immunity, and our medical arsenal would be blank. This is the point where the scenario can feel overwhelmingly terrifying. It's easy to imagine a single thawing Neanderthal unleashing a caveman COVID that wipes out humanity. But before we succumb to panic, we need to inject a heavy dose of scientific context. The risk is real, but its scale is debated. The first and biggest hurdle for any ancient pathogen is us. Humans are a very specific host. Most viruses and bacteria are specialists. They infect a particular type of plant, animal, or bacteria. The chance that a random virus thawing from the ice is not only capable of infecting a human cell, but also of spreading from human to human is extremely low. The vast majority of microbes in the environment are harmless to us. Furthermore, for a pandemic to take hold, the pathogen needs a perfect storm of conditions. It needs to find a human host quickly before it degrades in the sunlight. That human needs to come into contact with others, spreading it effectively. Our modern world, with its global air travel, is a double-edged sword. It could spread a disease rapidly, but it also means our global health surveillance systems are more advanced than ever. Organizations like the WHO and the CDC are constantly monitoring for novel outbreaks. The key is vigilance. The threat is less likely to be a dramatic patient zero from a glacier and more likely to be a slow, steady release of unknown microbes into the environment with unpredictable consequences for ecosystems. The greater immediate threat from melting permafrost is the release of vast amounts of methane, a potent greenhouse gas, which would accelerate climate change far more dramatically than any single virus ever could. While the narrative of zombie viruses captures the imagination, it's crucial to remember that the melting ice is also an unparalleled source of scientific discovery, a window into our planet's past. The same ice that might hold pathogens also holds priceless information. The ice cores drilled from glaciers like those in Greenland and Antarctica contain tiny bubbles of ancient air. By analyzing these bubbles, scientists can reconstruct the Earth's atmosphere from hundreds of thousands of years ago, giving us critical data about past climate change and helping us model our future. The permafrost has yielded perfectly preserved specimens that would have otherwise completely decomposed. A cave lion cub named Sparta, found in Siberia with her fur, skin, and whiskers intact, looking as if she were merely sleeping. A 40,000-year-old wolf head, complete with brain tissue. These finds are not just museum pieces. They allow geneticists to sequence the DNA of extinct species, understanding their biology, their evolution, and the ecosystems they lived in. The ice is giving us the library of lost worlds. The challenge, then, is not to seal off the Arctic and never go back. The challenge is to approach it with respect, caution, and rigorous science. We need to treat these areas not as barren wastelands, but as the unique and fragile archaeological sites they are. The story of the ancient viruses in the ice is ultimately a story about our present and our future. We are not passive observers of this thaw. We are the catalysts. The accelerated melting of the world's cryosphere, its icy regions, is a direct consequence of human-driven climate change. In a profound and unsettling irony, the very actions that are warming the planet are now unlocking its deepest, oldest secrets and potentially its oldest dangers. The image of a 30,000-year-old virus waking